next topic, and oxygen compounds deals with ethers. Now, ethers used to be a big thing, or not much anymore because of they're a very dangerous compound. I had a professor at McMurray College where I got my bachelor's, and he took over the chemistry department in my senior year. He went through the lab and found a bottle of ether that was supposed to be colorless, was bright red, and he freaked out, cleared out the building. They called it the bomb squad from Scott Air Force Base, not too far from us. They had to very gingerly take it out of there because if someone were to jostle it, it would have exploded on them. So they took it out to the middle of the soccer field and they shot it. And this was the most glorious explosion you've ever seen. We all cheered them, except for the ticked off soccer team. We laughed because I played baseball, right? As long as they didn't do it in my field, I was fine. Anyway, so that's the deal with ethers. But let's talk about the definition of ethers first before we get too into this. We said alcohols is this right here. We have a hydrogen bonding to an oxygen, which is bonding to an alcohol. If you took that hydrogen off and replace it with another alkyl group, which may or may not be the same length or same number of carbons as the original alkyl group, it doesn't make any difference. The prime is saying this is in addition to it, not different necessarily, although most of the time it is. We're going to be dealing with our reactions with what we call symmetrical ethers, meaning they have the same number of carbons on each side of the oxygen. All right, so that is the definition of ether, and you'll see it written like this: ROR prime, with the understanding that there is a single bond between the alkyl group and the oxygen. Okay, so that's our definition of ether. So, again, we're dealing with, we're going to talk about physical properties. We're dealing with oxygen, which again is the second most electronegative element on the periodic chart next to fluorine. So, there's going to be some polarity issues here. So, if we take a look at a rather geometric look at it, we've got these pair of electrons right here, this electron right here. You can see that this is a polar molecule. So the fact that it's polar means that it is soluble in water up to around 6 carbons. Okay, same deal as the alcohols. In fact, you may as well say it for every single one of these oxyorganic, including the amines. They're all going to be polar. They're all going to be soluble in water up to about 6 carbons. Okay? But I'm going to say it anyway, just to make sure that you can see it in front of your face each time. But here's the difference. You'll notice that the oxygen has no hydrogen bonding to it. Okay? So that means then that the intermolecular bonding, which I'll abbreviate as IM bonding, James bonding, okay, so the intermolecular bonding here is different from the alcohols because we have no hydrogen bonding to the oxygen. So what kind of intermolecular bonding are we dealing with? Dipole-dipole. Now, this is a middling strength intermolecular bond. It's not as strong as the hydrogen bond, and it's way stronger than the van der Waals forces. So that means that it's going to have medium vapor pressure. But a lot higher vapor pressure than the alcohols, but a lot lower vapor pressure than the hydrocarbons, which are all held together by van der Waals forces. And like I said, you know right away when you have it. Now, I don't know how many of you work with automobiles and dirty engines, but one of the things we use ethers for is cleaning out the gunk. In fact, I think there's a product called Gunk Away or something like that. That is mainly ethyl ether, which used to be used as an anesthetic in surgeries. And when you open up a bottle of gunk away or whatever that thing is called, man, you know it right away. It just smacks you right in the nose, which is where it should be smacking you because that's where your sensors are for your smell. So, medium vapor pressure, but higher vapor pressure than alcohols, which means also it's going to have medium boiling points. Lower than alcohols, but higher than hydrocarbons. Okay? That takes care of the physical properties. Uses. We talked about a little bit. Diethyl ether was at one time a very common anesthetic. I guess it's still being used somewhat. They've had it since the days of the Civil War. We were sawing legs off of soldiers who have destroyed legs from the shells. They did have it, there was a rumor going around, oh no, the Civil War, they didn't have it, they had to bite down on a bullet. If they did that, it's true, it did happen, but that's not because it wasn't there. They just didn't have it available to them. Sometimes they ran out. The blood was so bad. Like I said, it's a cleaner of oil and grease off the car engines. Diethyl ether is also a fuel. And methylphenyl ether is used by some insects as a form of communication between them known as pheromone. Pheromones is a really interesting topic. We haven't talked to you about pheromones, just we had so many things to talk about, but I think pheromones is one of the most interesting things that people are not really that familiar with. When women put perfume on, or guys put on aftershave, you're putting on a chemical to attract the opposite sex. That is a type of pheromone. A pheromone is also like cockroaches. Cockroaches, when they see food, they emit a compound out of them that permeates through all over the place. It's 11 carbon chain, undecane, and that undecane is picked up by all the cockroaches. They go to where the odor originated. That's how come they don't all travel in groups. One little cockroach finds it, spreads out this undecane to everybody who wants to inhabit this tasty treat, and there they all come. So when you turn on the light, you haven't seen a bunch of cockroaches scatter. It wasn't a nest necessarily to begin with. It was just friends coming over to have a buffet.